In today's class, we're going to be considering square and square root of numbers. We'll start with square of a number is a product of numbers and itself. So when you square a number, it's like you're multiplying the number by itself. Okay? And also you can say this is the value obtained when a number is raised to the power of 2. So when you multiply a number by itself or you raise the number to the power of 2, you're actually doing the same thing. So what you obtain from that is the square of that number. So for instance, x squared can be written as x raised to the power of 2. So if the x is squared, it means x is raised to the power of 2. And it can also be expressed as x multiplied by x, that is x multiplied by itself. That understood? Alright, we'll take few examples. 1 squared. 1 squared is equal to 1 multiplied by 1, and that is going to give you 1. Next, 2 squared equals 2 multiplied by 2, and that's going to give 4. 3 squared equals 3 multiplied by 3, that equals 9. Now 4 squared is 4 multiplied by 4 equals 16. Let's demarcate this page. We have 5 squared, or 5 raised to the power of 2, is equal to 5 multiplied by 5, and that is 25. Okay, here we have 6 squared equals 6 multiplied by 6, and that is 36. Now 7 raised to the power of 2, or 7 squared, equals 7 multiplied by 7, and that is 49. 8 squared equals 8 multiplied by 8, that is equals 64. Now squares of algebra. When I say algebra means using alphabet and numbers together. Okay, for instance, in these examples, here we have a squared. So like we did in the previous page, s squared simply means s multiplied by x. Now here a squared equals a multiplied by a, and that is still giving us a squared. There is no any other way we can express it. Here we have 2a squared, and that is equal to 2 multiplied by a multiplied by a. Now you need to be careful. This squared is not affecting this 2. This power of 2 is not affecting this 2. You need to be careful. Okay, and that is still 2a squared. Now the next one here, we have 4a into the bracket all squared, and that is going to be equal to, like you have it on the screen, 4a multiplied by 4a. So how do we go about that? You first pick the digits, the figures. So that is going to be 4 multiplied by 4. Okay, that's 4 multiplied by 4, then multiplied by a multiplied by a. I hope that is understood. 4 multiplied by 4, then multiplied by a multiplied by a. So your 4 multiplied by 4 gives 16, and a multiplied by a gives a squared. Okay, now square of fractions. Here in this example, we're going to be considering a squared over b. A squared over b can be written as a multiplied by a all over b, and that is still a squared over b. No any other way of expressing that. Here we have a over b all squared in the bracket, a all over b all squared. So the whole fraction is squared. Remember here, it's only the numerator here that is squared. The denominator is not squared. So here we have a over b. Now that's going to be equal to a multiplied by a all over b multiplied by b. The square affects a here, and it also affects b, but here it only affects a. So equals a squared over b squared. So this can also be written as this. Alright, so we have square of negative values. So how do we go about that? We have minus a squared. So minus a squared simply means minus a multiplied by minus a. That is minus a multiplied by itself. The next thing we'll do there is minus will multiply minus, or the two minus will be cancelled out, and to give us plus. And that's going to be plus a squared. And our plus a squared is the same thing as a squared. Okay, this plus a squared is the same thing as a squared. Next, minus 3a squared. This simply means minus 3a multiplied by minus 3a. So like we did in the previous example, we'll first pick the two digits, minus 3 multiplied by minus 3. Okay, first pick minus 3 multiplied by minus 3. Then we'll bring out the two a's multiplied by a multiplied by a. That is 9a squared. Next, minus 3a squared. Now get a difference between the previous example and this new example. The previous example, minus 3 and a were both affected. Here, minus 3 is not affected. A is only affected. So a is only squared. Minus 3 is not squared. So that is going to give us minus 3 multiplied by a multiplied by a. Why? It's only a that is squared. Minus 3 is not squared. So that equals minus 3a squared. Okay? Now, the last one I think in this example, minus 3a over 5 all squared. And that is simply minus 3a over 5 multiplied by minus 3a over 5. Now we'll multiply the two negative sign out, okay, to give us positive, and that is going to be equal to 9a squared over 25. How? 3a multiplied by 3a will give 9a squared over 5 multiplied by 5 will give 25. Alright, squares of sort or roots values. So the square root of x or root s can be expressed as root x raised to the power of 2, or this. Still the same way, either the one here or the one here, they are still root s raised to the power of 2. Okay, and how do we go about that? If you want to express this is a way of expressing this. It simply means root x multiplied by root x, and the answer there is x itself. So the root of a value multiplied by the root of the same value, the answer is the value. Please take note of that, it's very important. So root a multiplied by root a will give a. Root b multiplied by root b will give b. Okay, so let's take a look at some examples under this category. Here we have root 5 multiplied by root 5, and that's just 5. Here we have root a over 5 all squared, and that is simply root a over 5 multiplied by root a over 5, and that is a over 5. Okay, why? We are having the same value in the two roots. The answer is going to be a over 5. Simplifying square root of numbers, we are going to dwell much on this side. So we're going to be using prime factors to find the square root of numbers. Okay, so there are two categories of numbers in this regard. Okay, the first one is perfect roots, and the second one is solved. So what are perfect roots? Perfect roots are roots of numbers that will give whole number, unlike solved. Solved is the otherwise. So when you look for solved is just the square root of numbers that are not perfect root or perfect square. Okay, so take for instance here, when you look for root 25, you have 5. So when you simplify root 25, you will have a whole number. Why? 25 is a perfect root. Also, you have root 64, and our answer is 8. But here in this category, you have root 75. So simplifying root 75, you're going to be having 5 root 3 in solved form. Understood? If you want to get that using a calculator, like you having 75 roots, so you can see this long crazy number that we are having here. So this shows that 75 is not a perfect root or a perfect square. Alright, I want to simplify this following without using calculator. I want to simplify without using calculator. Now somebody may ask, what is the need for finding the square root of numbers without the use of calculator? Any need for that? Alright, I've been in an examination where I am not permitted to use my calculator. It's only myself and my brain and nothing else, possibly with the paper I'm working with. Okay, so who knows, the next few weeks you may find yourself in the same situation, so you need to train your brain for that. So just follow these few steps. Alright, now we'll take a few examples. We want to look for the root of these numbers without the use of your calculator or a table. I've given you reasons why you need to be used to your brain and not a calculator or a computer. So here I'm going to be using prime factors to find out the square root of these following numbers. I have a lesson on expressing numbers as a product of prime factors or prime numbers. The link is down in the description box. If you know you don't understand things around prime numbers. Alright, solution. So what's going to be the first step? The first step, we're going to be expressing 36 as product of prime factors. 2 is the list of the prime number that will divide 36 18 times. 2 is also the list of the prime numbers that will divide 18 9 times. Next we have 3. 3 will divide 9. 2 will not divide 9. Otherwise there will be remainder. So 3 divides 9 3 times, and 3 also divides itself just once. That's why we have 1 here. Now, now what we have here, we've been able to express 36 as a product of prime here. Now the next thing we'll do is we pair up all the factors we have here by saying 2 multiplied by 2 will give us 2 squared, 3 multiplied by 3 will give us 3 squared, and we'll write that out. That's going to be 2 squared multiplied by 3 squared. So the next thing we'll do is we'll pick one of them each. Instead of writing 2 squared, you write 2, then multiplied by, instead of writing 3 squared, you have, so you multiply out 2 multiplied by 3. The answer there is 6. So the answer to root 36 is 6, meaning that if 6 is multiplied by itself, you will have 36. So this is how to check. When you get any answer, multiply the answer by itself, you must get the value in the root box. Hope that is understood. Okay. Now, B. I want to simplify root 64. We are expressing 64 as a product of prime. 64 divided by 2, that is 32. 32 divided by 2, that is 16. 16 divided by 2, we have 8. 8 divided by 2, we have 4. 4 divided by 2, that is 2. And 2 divided by itself, we have 1. So, having 1 here, it shows we've been able to express 64 as a product of prime. The next thing, just like we did here the other time, we'll pair up, okay, in twos. We'll pair up in twos. Why? We're looking for square roots. So we'll pair up in twos, okay, just like we did here. So we'll write out our square. 2 squared multiplied by 2 squared multiplied by 2 squared. That is what we're going to be having here, okay. And instead of writing squared, you pick each of them, okay. Instead of writing the squared, you just pick one of them each. And that answer is 8. That is 2 multiplied by 2, 4 multiplied by 2, that is 8. Okay? Now to check. If 8 is multiplied by itself, will you get 64? If yes, then it means your answer is right. Next, we want to simplify root 144. Okay, still the same method. We have 72 here. When you divide 144 by 2, next we're still using 2. Divide 72 by 2. You have 36, 2 is still working, you have 18, 2, you have 9, 3, you have 3, 3, you have 1. Okay, now you pair up. Now 2 multiplied by 2 is 2 squared, 2 multiplied by 2, 2 squared, 3 multiplied by 3, that is 3 squared. Okay, then we'll bring that out. Multiplied by 2, multiplied by 2, multiplied by 3 equals 12. Okay. Now, how do you check your answer? You check your answer by multiplying 12 by itself. Okay, if you get 124, it shows your answer is right. Okay, we're going to be simplifying this without the use of calculator or table. Okay, so the first one, we want to simplify to root 5.76, and root 5.76 converted to fraction can be expressed as 576 divided by 100. How? The last digit here, the place value is hundredths. Yeah, the place value of this last digit here, 6, is hundredths. So removing the decimal, that you can express the whole thing as 576 then divided by 100. Okay, it can still be expressed separately. The whole root can be expressed as root 576 over root 100. Alright, so let's simplify root 576 and let's simplify root 100. Okay, so simplifying root 576, you pick 5 just gradually. So you pick 5 divided by 2, that is 2. We are left with 1. Alright, so you can see the red one bouncing. Okay, So the red one added to 7, that is 17. Pick 17 divided by 2, that is 8. Okay, we're still left with 1. So the second one has also bounced in. The red one added to 6, that is 16. The red one added to 6, that is 16. 16 divided by 2, that is 8. Okay, now 2 is still functional. Okay, you have 144. 2 still functional, you have 72. 2 still functional, 36. 2 still functional, 18. 9, 3, 3, 3, 1, just to save our time. Now we pair up. So when we pair up, we have this. Okay, and writing them out, we have 2 squared multiplied by 2 squared multiplied by 2 squared multiplied by 3 squared. So we write out each of them without the square. So that's going to be 2 multiplied by 2 multiplied by 2 multiplied by 3. Everything equals 24. Okay, now I want to simplify root 100 in this pearl green box. Okay, we have it this way. We have 50 here, we have 25, we have 5, and we have 1. Okay, so if we pair up, we're going to be having 2 squared multiplied by 5 squared. Now 2 multiplied by 5, that is 10. So we want to check. 24 multiplied by 24 must give you 556. 10 multiplied by 10 must give you 100. Okay, now remember, this is what we want to simplify. This is what we want to simplify. So bringing it down here, that is going to be equal to root 576 is 24, root 100 is 10. So you have 24 divided by 10, which is equal to 2.4. So to check, 2.4 multiplied by 2.4 must give 5.76. Okay, now we have root 20.25. So just like we did at the time, the last digit here has its place value to be hundredth. So taking this to fraction is still the same as 2025 all over 100. So splitting the roots is still the same as root 2025 all over root 100. Okay, so when we simplify this, we'll pick 20 divided by 3, that is 6. We are left with 2. Okay, so you see my red 2 bouncing in, then 2 added to 2, that is 22. 22 divided by 3, that is 7. Okay, I'm left with 1. See my red 1 bouncing in, my red 1 added to 5, that is 15. 15 divided by 3, that is 5. Okay, 3 is still functional. Yeah, make sure it's functional before you use it. So this time around I'm going to be having 225. 3 is still functional. Divide 225 by 3, you have 75. Still using 3, I have 25. Now 5, I have 5. 5, I have 1. Okay, now I stop and I pair my prime factors. Okay, so this is 3 squared multiplied by 3 squared multiplied by 5 squared. And the answer there is going to be 3 multiplied by 3 multiplied by 5, which is 45. Okay, so the next thing I want to do is I want to simplify root 100. Remember the other time when we simplify root 100 we got 10. Just to remember, we got 10. Okay, so to simplify what we need to simplify here, root 2025 is 45, then root 100 is 10. So we're going to be having 45 divided by 10. And our answer is 4.5. Okay, our final answer is 4.5. So when you multiply 4.5 by 4.5, you must get 20.25. Okay. The next example, here we're dealing with fraction. The first step, you take this to improper fraction. This is a mixed fraction. You change it to improper fraction by saying 25 multiplied by 5, that is 125. 125 added to 19, that's 144. Okay, then over to the 5, and that leads to what I have here. Again, 25 multiplied by 5, that is 125 added to 19, that is 144. So splitting the root, that is root 144 over root 25. Without wasting much of our time, root 144 is 12 and root 25 is 5. So expressing our answer in this same format, mixed number, then that is going to be 12 divided by 5, that is 2. I'm having 2 left, all over 5. So to check, 2 number 2 over 5 multiplied by 2 number 2 over 5, I must have 5 number 19 over 25. Okay, I want to simplify root 120. First, let's express 120 as a product prime. Okay, so here we have 60, make use of 2 we have 30, make use of 2 we have 15, make use of 3 we have 5, and finally we have 1. Okay, now 1 up here. What is happening here? Okay, let's pair. Now we can only pair the first 2. There is no any other set of numbers that we can pair again. Alright, we can only pair the first 2. So pairing the first 2 and writing it out, that's going to be 2. We're picking this first 2, you pick it, that is going to be 2, then multiplied by. Now you write out everything that are not paired. You write them out in a root box like this. I explain that again. Now you pick the squared, you write it out, just write one of it out, then multiplied by everything that is not squared, like I have them in this oval, 2 multiplied by 3 multiplied by 5. You write them out in a root box, just like this. And my answer is going to be 2 roots 2 multiplied by 3, that is 6, multiplied by 5, that is 30. So everything in the root box is 30 and 2 separate. So this is 2 root 30. Makes sense? Now here I have root 200. So expressing 200 as a product prime, I have this. Sorry, I'm not taking time to explain, but I just want to believe we understand it already. Now let's pair. Okay, let's pair up. So I can only pair the first 2 and the last 2 5. The first 2 digits and the last 2 5. I can now pick one of these, that is 2, and one of these, then 5. Again, I pick one of these, that is 2, and I pick one of these, that is 5. Then multiplied by the only 2 that is not paired is going to be in a root box, just like these ones are put in a root box. I'll put it in a root box, that is root 2. Okay, then multiply out what I have here. 2 multiplied by 5, that is 10. Then the one in my root box, root 2. Is that making sense? Yeah. Now these 2 examples are solved. Why? They are not perfect roots. So there is no any number that, so when multiplied by itself will give me 120. No, except in decimal or in fraction. So the same thing for 200. There is no whole number that can be multiplied by itself that will produce 200.